Hello, everybody, again. We are continuing our trip, our adventure for the architecture and DevOps teams track. And now with me is Milen Dyankov, who will tell us something about location transparency. So nice to meet you, Milen.
Nice to meet you. Nice to meet you, everyone. I hope you enjoying the conference so far.
It's good to hear. It's good to hear. Okay, so I saw the description of your presentation, and you are touching the really crucial and more really important things in each application. It's always hard to decouple things, to make
Yeah.
separate boundaries for different things. Even because I'm more related to cloud infrastructure and so on, but it both in infrastructure and it's in also in the software development side. And to be honest, I have never heard that term location transparency, so I'm even more interested in your presentation. But I have, let's say, kind of open question to you for the
All right.
beginning. Is there any possibility to enforce or to ensure that people will take care about that kind of decoupling things in the long term perspective. Yeah, because okay, now we can say that hey, okay, we are trying to decouple things, we are trying to rebuild the stuff, but with time it can back to the state it was previously. So maybe you have some kind of tips and tricks for doing
So, yeah. So, generally speaking, you can't force people to do anything unless they want to.
that.
uh, and the solution for everything that you want to exist is to make it easy enough for the people so they can use it. If it is easy, they will do it. If you make it complex, they will stop eventually. If it is too hard.
Yeah.
If something else shows up that makes it easier, they'll start using the new thing. So the if you want something to exist for a long period of time, you have to constantly make sure that that is easy and convenient for people, and then they're gonna do it. Otherwise, hey, people have tried with rules and laws, and we all know how that works.
Yeah, exactly. But always someone will broke that rules, and
Yeah,
everything can be moved to
exactly.
trash. Okay, the floor is yours, and keeping fingers crossed for your session for you.
All right, thank you very much. I need to rearrange my screen a little bit here to start sharing. Let me find my presentation because it's going to be much easier and much better for everyone to look at some slides and pictures rather than looking at me.
Yeah, it's visible now, so we can.
All right, good. Okay, which way should I go? Here, I guess. All right, so hello and welcome everyone. Glad to be able to talk to you about location transparency today. Unfortunately, can't see you, and this presentation is meant to be a little bit interactive and a little bit depending on your reaction to things, which I'm not going to get that feedback here, but let's hope it's gonna work out well. As I was introduced, my name is Milen Dyankov. I work as a developer advocate for Axonic. Axonic is a company that provides a couple of products for event-driven for developers who build event-driven systems. It's mainly around Java and JVM-based languages. We also have some work going on in .NET and in .NET space, but that's future. It's interesting because I've been in the industry for close to 30 years now, and like witnessed the whole DevOps movement starting from zero. One interesting thing about DevOps is that the more people, when you talk to people, it seems like most of the people see it as like mostly ops with a little bit of devs, or mostly devs with a little bit of ops. And it's like I kind of have the feeling that it was never like 50-50 kind of thing. Um, so there is this focus on which I guess comes naturally. It depends on who comes from what background. So if in that concept, my I'm more on the dev than the ops side, And that talk is going to be more on the dev than the upside. So no Kubernetes and fancy infrastructure things, but more about application architecture and how we build applications so that they work regardless of what the deployment strategy for those applications is. So that's about me. And let me go, here you go. It works. And that's where I live. That's where me and my family live. It's a house in a city. It's quite convenient. It works well for all of us. My kids are especially happy with it because it's very close to their school. They have convenient transportation. It's not so great about my wife though, because she's more of a seaside person. She loves to go to to be close to the sea. So we couldn't solve that problem. So we kind of chopped a bit of piece of that house and move it on the seaside now. And so that's where my wife is now feeling absolutely happy. She can just walk out of the house and be on the beach. But that doesn't work really well for me because I'm more of a mountain person. So I typically like to go and see things from high above. So we decided we can get another piece of the house and move it to the mountain. So this is where I live. And now everyone's happy, kids are happy, my wife's happy, I'm happy. It's a little challenging when we need to get together for a dinner or something because we need to have to drive several hundred kilometers, but that's not a big deal. It's workable. And that's the part where I said that the presentation depends on your reaction because typically it's where I ask people if they buy the story and they start laughing because absolutely this story is not believable. And if you did, I'm sorry, didn't want to lie to you. It's just an illustration of a absurd, of something that I can tell you a story and you can immediately sense that this is nonsense, right? But I can tell you the same story in a different way, and now it's gonna be much more believable. So this is my application, and it was a beautiful monolith. And at some point in time, I decided that I'm just gonna chop bits and pieces of it and deploy it in a different environment, and I'm gonna chop another bit on it and deploy it in a different environment. And now I have a collection of microservices which are super happy working together, collaboration, orchestration, whatever term you want to use there. And everything is the world's now beautiful. Now, that second story is much more believable, isn't why is that? Because you don't see typically all the complexities and correlations and tight couplings and all the things that are behind the scenes. When you draw boxes on a white screen or on a whiteboard or the presentation, that seems very easy. That seems very doable. That seems very, very realistic. So one thing that I started wondering some time ago, and that probably you should be wondering also, is why is it that depends on how we describe a case, we can immediately sense the nonsense, or we cannot sense it until it's too late, right? The story about the house was like the first image I show you with the half of the house moved somewhere, you knew it's a nonsense, right? But when you just draw diagrams and draw lines on paper or in whatever modeling tool you have, you don't sense it. It's believable. It sounds realistic. And I argue that the reason why we sense it when it comes down to physical objects and the environment that we live in is because we have a natural sense for coherence in those cases. Now, coherence is a term that's being used here and there, but essentially, and it maybe different people have different meanings, but essentially, what coherence is about things that naturally uh, belong together. It's logical for them to be together, and they form something together. And so, to give you an example, imagine you travel by train, and you and your personal belongings, such as your hand luggage or your coat and stuff, it is absolutely logical and common and makes absolutely sense to travel together. Now, picture a trip where you've been asked to go in a coach or a train car, for example, but all the stuff that you have with you, including your code and I don't know, and back and that goes to some other place and travels by some other means, and then there is some algorithm that you meet with your belongings somewhere and get them back. That would be a nonsense. If someone would tell you this is how we organize trips, right? You'd be like, no, I really want my bag with me. I really want my coat with me, right? Because that's coherence. That makes sense, right? And it does not make sense to split it in that place, right? But we don't talk too much about coherence in building applications, or not as much as we talk about coupling. Now, coupling is a little bit different. Coupling happens when we combine things together for a particular purpose. For example, you can think of the trains, cars. Uh, they are coupled together. One is connected to the other. One is connected to the other. And we do this because that makes it easier to drive the whole thing with a single engine. Right? You put the engine in front and you drive 20, 30, whatever cars are connected to it. Right? So they're coupled for a specific reason, but theoretically you could decouple them. You could put an engine in front of each of the car, and you will, financial aspects aside, you would have the same result, right? It will still bring the train from point A to point B in pieces, right? So coupling is something that you introduce because it makes some sort of technical sense, some sort of improvement, something that um, um, uh, that is better optimized, if you will, right? But it's not. It's not because it belongs together. It's not because it must be this way, because otherwise it makes no sense, right? And so when things are coupled, you can decouple them. But when they're coherent, you should not try to split them apart. Now, there is another term that I like a lot, and it comes from this book's Fundamentals of Object-Oriented Design in UML by Mailer P. Jones, and the term is connaissance. And connaissance is essentially the when you have two or more objects that are born and live together, right? So, and then when one of them changes, the other one needs to change too, right? They have kind of common or shared, if you will, life cycle, right? And so, for example, you can think of the rails and the distance between the wheels, right? You cannot change that one and not change the other. If you make wider rails, then you have to change all the trains to have wider distance in between the wheels, or narrower, or whatever. So there is a connaissance there between the two seemingly independent things, right? There are different factories that produce railroads and materials for railroads, and different factories that produce trains and train cars. But there is a connaissance between the two. You have to be able to you have to know how it is one and adjust the other to it at the end when you lay down your infrastructure. But enough with this abstract talks. Let's look into code. And since I'm a Java developer, most of the examples will be in Java. I hope that they're simple enough for you to understand, if you know, even if you're not a Java developer. So here is a simple piece of code in Java. It's a fragment of code from something that is supposed to buy a program that you can use to buy tickets to attractions. And so there is a connaissance in that code, and you may not immediately see it, but it's what we call a connaissance of name. So you cannot change the name of the field or variable, or whatever it is called in your language, with the definition, without changing every single place where that field or variable is used. That's what we call connaissance of name, and we don't typically think about it because currently we are at the level of software development where IDEs take care of those things for us, in a blink of an eye. So you probably have some sort of refactoring tool, and you don't even notice how it changes it everywhere it needs to change. But there is a connaissance. It has to be done. The fact that it's easy to do does not change the fact that there is a connaissance of name. But on that very same code, there is another connaissance, and that is a connaissance of type. You have the type of that variable field, which is being declared somewhere, and then use it as an argument for a function. And though there is a connaissance between those two, you cannot change the type in one place and not change it in the other. And again, connaissance of type is something that IDEs are pretty good at. They also keep track of those things. They can do it for you, and that's why we don't bother too much about those, and we don't typically speak about those on a daily basis. But it's good to know that they're there. So connaissance of name and connaissance of type, so those two connaissances that we call a very low-level connaissance. Right? Those are the easy ones. Those are the ones that are almost always there, and we can deal with them, right? And they're not a big deal. But they're different. A lot more different types of connaissance. So if you are familiar with Java, you can look at that code, and even if you're familiar with Java, it may be hard for you to spot a connaissance here, but there is one, and it's a connaissance of an algorithm or convention, depends on how you want to look into it. So in here, we are buying ticket that allows you to go to several different attractions. And on one side, you have the code that actually executes that logic. On the other hand, you have the code that calls that logic. And in what you have here, what you look into the implementation, you would see that there is an assumption there that when you get the list of the attractions, the first one is the main attractions, and all of the others are the remaining attractions, right? And now that is how it is being called. When you build the list to purchase a ticket, you have to put the main attraction first. Now, if that algorithm or that convention changes in one of those places, it has to change in the other place too, or unpredictable things will happen within your application, right? A way to mitigate that is to explicitly provide arguments for the main attraction and the rest of the attractions. But still, from the execution perspective, you provide a list, and then you have things called a connaissance of position, right? You still need to know which argument of what is the order of the arguments for that particular function. And if you switch places, unpredictable things will happen with your application. So I'm not going to go through all of the connaissance that the book describes. Feel free to go and examine it. I think it's a knowledge worth having. But there's also a connaissance of execution, connaissance of timing, connaissance of value when you have different pieces of code, two or more pieces of code that expects the value of something to be exactly the same, or connaissance of identity when you expect different pieces of code to reference exactly the same object or ID, and whatnot. One that is actually particularly interesting is what it's also called contrannessence. And it's also another thing that we often don't think about it. It's for example, the fact that if you name a variable somehow, you cannot have another variable with the same name. So it's the negative of connaissance. It's limiting you. It tells you now you've chosen that name already, you can't have another one. And again, it's super simple when we talk about names, but it also applies to larger fragments of code, because you assume the logic here, you cannot do something over there. So there's also contrannessence of all those. And so when we start thinking about connaissance, the natural question that pops up, or at least it pops up for me, is what's behind it? What's causing it? Why? Okay, we obviously have connaissance, and we obviously cannot get rid of it. But is it because of coherence, or is it because of coupling? Is it because the things are so naturally together that we don't that it just they have to live together? Or is it because we design it this way because of convenience, or because of someone told us some practices and we just blindly apply them? So few years back, I discovered this book. It's pretty old. It's called Domain-Driven Design by Eric Evans. And actually, the subtitle is more interesting. It's Tackling Complexity at the Heart of Software. Highly recommend you to read it if you haven't. But there he talks about many things. There's a lot of great ideas there. But one of the things he defines there is the term aggregate. And an aggregate is a cluster of associated objects, so multiple things, which we treat together as a single thing with respect to change. Like whenever there has to be a change, we get that collection of objects and we treat it as a one thing. And it has a root, which is the object that that the outside world interact with, and it also defines boundaries. So within the aggregate, there is all these things that tightly coupled together, if you will. But from the outside world, and that's the boundary of the aggregate, which is between the internal components and the outside world, it appears as a single thing. And now, if you compare aggregate, the definition of aggregate with the definition of coherence, you'll see quite a lot of similarity, right? And the ability to form a unified whole, and the need to keep the internals logical and consistent. They are and have boundaries, and to be able to tell what belongs inside and what is outside. Those things are very similar. So when you design applications, if you do domain-driven design, what you try to do is to design the aggregates in a way that all the higher connaissance is within the aggregate. So an aggregate's a collection of objects, and obviously they have a reason to be together. So all this high level of connaissance, like connaissance of algorithms or um, um, order or a position, whatnot, they are naturally within the aggregate, right? But you don't have to do aggregates. You can just do design your data structures or objects or whatever is in your group this way, that in everything within the boundaries of a coherent thing can have high connaissance. What you really want to avoid is high connaissance in between those things, right? And so when you have one aggregate talking to another aggregate or to another coherent object, what you want is a lower connaissance, right? But how do you do that? Well, normally these two will talk by exchanging some sort of data, right? And for now, let's just call it the data. And what we can do is we can assure that there's going to be obviously some relation between the object on the left and the data, and the object on the right and the data, right? So what we need to do is to ensure that the connaissance between those objects and the data is at most connaissance of name or connaissance of type, most likely both, because those are the easiest types of connaissance to deal with. Like any ID can deal with that. If you introduce high-level connaissance there, the things become complicated, and separating those things becomes more and more complex. All right. Now, let's arrows. That's one of my favorite things every time I look at software diagrams, is that people draw boxes and arrows, and they focus 99% of the time on the boxes, and they assume that the arrows are like given. It's just okay, like, yeah, this is going to talk to that. And but I would argue that how one thing talks to another thing actually introduces another type of connaissance, which we call the connaissance of location, right? And that's not in the original book, but I would argue it exists. So let me give you an example of that. So there is a connaissance of location in that code. That's a very simple Java class, which has two methods, one method calling the other method. Now, what you may or may not immediately realize from this code is that there is an assumption in here that both those are in the same class. Now, if you grab one of those and put it in a different Java class, that code is not going to work anymore. So there is a essence of location here. There is an assumption behind the scenes that both are in the same class. Okay, so what you can do is you can extract that into a class, right? And then use the class as a reference and call that method from a different class. Of course, you can do that with Java. But there is another assumption in here, and which is that both of those need to be in the same package. If you get one of those and put it in a different package, that code's not going to work. Okay, you can work around that by importing a package or a class from another package, right? But there is another assumption behind the scenes here that both are on the same class path or module path or whatever next thing Java comes up with, right? So again, we don't think about those things, but there is the assumption that a jar file or a directory contains that and it's accessible by the JVM, for example. And so you can then say, okay, I'm done with this. What I'm going to do is I'm going to go full web services, RESTful services, and whatnot. So here on the top, basically you have a client that reaches out to some RESTful service somewhere, sends a JSON, returns a JSON, parses, whatnot. And on the bottom, you have a typical RESTful application written in Java, which you expose at some URL, right? So no more location issues in here, right? No connaissance of location. Well, there is. First of all, this too needs to be configured exactly the same way. So whatever is your configuration for the server, whatever you expose it, the client needs to be aware of that, right? And it also needs to be aware of all the paths that you potentially use to reach out to that particular service. And so then you go like, okay, I'm not going to do it this way. I'm going to just use a event-driven approach. And so I'm just going to have some sort of event bus. I'm going to send events. I'm going to receive events. Do we have a problem here? Well, yes, because normally those event buses use things like topics or streams or whatever the solution is. And then you now even have connections between three things, because you need to define that topic or that stream or whatever that thing is in the messaging solution. And then you also have a connections between the client and the messaging solution, and between the messaging solution and the server, and the other way around. So there is there is an assumption, and for this to work, the assumption is that they all going to use the same stream or topic. So what all this introduces is a location awareness. For your application to work properly, you have to be aware of where the other thing is. Now, how complex that is, that's a different story. It depends on like how they implemented it. But there is this notion of location awareness, which we may or may not notice. So is there any way to deal with that? Can we, regardless of everything, bring this down to a connaissance of name and time? I think we can if we stop thinking about this as a piece of data or message or whatever you want to call it. As a message, as a one universal thing. I actually heard a presentation just before mine that someone was explaining how hard it is to debug message-driven systems. And partially, he was right, but that's partially because we tend to think about messages as a like universal thing. But what if we start actually distinguish the different types of messages that we have? So we have messages that are commands, right? We have message that's being sent that carries a specific instruction to someone. It says do something, right? We have messages that are events. They carry a notification about something that has happened somewhere. That's purely information. And those are delivered to multiple recipients typically. And then we have messages that are requests for information. Basically say, tell me what's the outcome of this, for example. So the commands types of messages are typically routed to a single handler, and typically don't expect results. The events are distributed to anyone who is interested in what has happened, and they don't expect any results. And the queries are typically load balanced to some components that can answer the questions. And the most important thing is the result. So when you talk about event-driven systems and you try to put everything under the event label, you get something that I called passive-aggressive events. You have commands and queries that are masqueraded as events. Right? When you start talking about message-driven systems, you are still way too abstract. You assume all messages are different, are equal, but messages have different routing patterns. Depends on what messages we talk about. Whether you distribute it to a single receiver or multiple receivers, or do you pick? Can you pick, or do you should you stick to the one that get the first? So depends on the type of the message. There are different routing patterns. And it's also they differ in whether or not they expect a result. When you send a command, you typically would want some sort of confirmation that someone is taking care of that, right? You don't expect as a response as such, but some sort of confirmation comes nice. If you do events, you don't. You just send it, and whoever needs to know knows. When you do queries, everything you care about is the result, right? If there's no result, like it doesn't really matter where that your message was delivered. All right. So there are different patterns how we deal with messages depends on what that message is about. And so what if we start modeling those messages the way they are? Here is an example in Java in which we model these three types of messages as Java classes. So the orange one is a command, the blue is an event, and the green one is a query. And the query is a little bit bigger because it also defines what is the type of the result that you expect to receive. Now, when you have those, you can have a message router that is just intelligent enough to understand the three types of messages and the different routing patterns they follow. So you may recall, if you've been in the industry long enough, that we used to have these big ESB systems and stuff like that, and then we told like, no, that's too complex. Let's go to what was it, smart endpoints and dump pipes and stuff like that. Well, I think we went to two dump pipes, right? So if we agree that the pipes can may not be as dump as they are at the moment, and just teach them a little bit of the routing patterns of the different types of messages, we can achieve more things. So then you have the producers who produce not just messages but specific types of messages, and the message router knows how to handle them. And so here is an example on Java code where you grab a thing called command gateway and you just send that command object that we defined earlier. Or you have an event gateway and where event object that we defined earlier, or you have a query gateway where you can query for the results that you need. Again, it's not too different from just grabbing a stream and putting and throwing things at messages at there, but it brings a semantic that is very important. And the same thing, then the message router, understanding those specifics, can figure out which components it needs to route objects to. Right. So those consumers can register themselves, and in this particular case, that's done by Java annotations. So we have different regular Java classes where we say there's a command handler, there's an event handler, and there's a query handler. And they also have the type of the command or the type of the event or the type of the query that they can handle. So that's all the message router needs to know. It needs to know what type, the three types of messages, and it needs to know who can handle what so we can do the proper routing. So Now you have a situation which is a very similar to what you would have with a normal message router, but this one is a little bit more intelligent, and it can do things that um, uh, to optimize things in the process. And what does that give you? That give you location transparency. You don't have to subscribe to specific topic or specific stream. All you have to do is you say, I'm sending this type of message with this payload, and the router is intelligent enough to figure out where to deliver it and how to handle it. And that is essentially why we developed Accent Framework. That's like one of the fundamental things that Accent Framework does. It was born to help developers deal with domain-driven design, security, and event sourcing. But in order to properly deal with those concepts, location transparency is a key feature. You need to be able to communicate with other components of your systems without having to constantly know where they are located and how to reach them. Um, so, in those components, within the group of objects that they represent, you have higher connections. How they are connected, you can have references, you can have connections of algorithm and whatnot. That's okay because they are coherent. They need to be coherent by design. But in between the communication in between those, you have only connections of name and type. You need to know that is a command query or event and the specific type. And that's it. You are at this point, you are location transparent, right? You don't need to know where the other component is located. Now, that allows you to deploy an application as a single deployment unit in a single JVM in case of Java, or a single Docker, or whatever your preferred solution is. But when you want to scale that up and split it down into microservices, now you know where you can cut and where you cannot cut. You can cut everywhere where your location transparent, but you cannot cut within the boundaries of the coherence. So you're not trying to split your components, those circles, but you can split through to everything to all the communications in between them. And that's why we developed these two other products, Accent Server and Axonic Cloud, which is a software as a service version of the Accent Server, which allows you to do the same thing but distributed. So now you can grab your application, and without even changing a line of code, you can just replace the messaging infrastructure, and you can start talking to components that are no longer in your JVM on your machine and together in your application, but you can deploy them in different places, in different scenarios, and everything works exactly the same. And the key factor allowing this to happen is location transparency. If you have built the application in a location transparent way, that means you know where you can cut the line and move things somewhere else. If you haven't, splitting it down is always a risk. You don't know if you split components into 2 parts or 3 parts, what's going to happen, right? What's going to be the side effect? What connections you're violating, what coherence are breaking, and whatnot. So this is what we do. This is what we try to help Java developers also primarily work with. The 3 products, in case you're interested to look deeper into that, are Accent Framework, Accent Server, and Axonic Cloud. There's a bunch of other products around that, which I'm not going to bother you with. They're the URLs. Accent Framework is 100% open source. Accent Server is free to use. There is also Accent Server Enterprise, which allows you to do multiple bounded context, clustering, and whatnot. And Axonic Cloud also has the free tier. So if you want to use it for free to certain amount of messages, that's also there for you to try out. The reason we have those is to help developers build domain-driven design, event sourcing, and security-based applications. And the fundamental part of that is to build location transparent applications that can scale from monoliths to microservices and go back if you need to without too much of a hassle. So that is pretty much everything that I wanted to share with you today. And I think I hope you like it, and I hope it was useful. And now I'm gonna open it for questions. And just before that, there are some links on the right side of the slide. We also have this thing called Academy, which we started building about a year ago, and we have some free courses there. So if all the topics about domain-driven design, event sourcing, and secure S are new to you, you can just go there and learn those for free, and then you can dive into more detailed courses if you need. Um, uh, that is also my Twitter handle and email. If you don't want to send the feedback now but want to do it later, please do. I'm more than happy to chat with anyone to discuss any topic. Um, Thank you for attending. Opening up for questions now.
Yeah, thank you, Milan, for your presentation. It was really great. And personally, yeah, as you said during your presentation, we are thinking about that services, how they should be split, how they should be built, constructed, and so on. But we are not thinking about that, sticking to that location. And thanks for naming that. Hey, we have the location connaissance in that place. So yeah, and even better for showing us that hey, we can use CQRS and even event based messaging for taking that complexity from our hands. So we have one question on the
Yeah,
chat.
sure.
Great explanation for why we need to be transparent about the location. I like the way you combine DDD, CQRS, and event sources. One problem I usually have is gathering information about aggregation route. Could you share some ideas on how to do it? Do you really get all the information related to aggregated route or only partial? How DDD design is affected when you try to filter data about aggregation route in command query?
I can answer how we do it at Exonic and how we do it with other products. I know different solutions are doing it, and I know the challenge. I wouldn't call it a problem, but it's a challenge. And then I know different products address it in a different way. So the biggest Axon framework was designed for Java JVM languages. So we operate in the nomenclature of Java, right? So for what we design is an aggregate is an object, and everything that all the other objects that like entities and value objects, they are directly linked to that object. And so from Java perspective, we have the aggregate being both sorry, we have the Java object being both the aggregate and the aggregate root, right? And so then we use CQRS for all the communication. And so an aggregate that Java objects can define command handlers. And this is how you communicate with the aggregate. So you don't actually have to find your root. Right, you don't have to go and have a way of figuring out which is the aggregate root. All you have to do from consumer perspective is to construct the right command, and then you send the command through a command bus or gateway, and commands can be handled either on a method level or on a constructor level. So even if you are to create a new instance of the aggregate, you can still do it with a command. You can send the command create new shopping cart, right? And that command is going to go and figure out, oh, there is a shopping cart aggregate, right? And create a new instance of that shopping cart aggregate, and it's going to give you an ID. And then the next time, and then that's what you get as a result, like the identifier of the aggregate. And the next time you send the command and say, put a product with identifier whatever to a shopping cart with an identifier whatever, right? And it's also going to immediately find that very instance of that aggregate and send that command, which will be handled and processed. So that's how we deal with it. With other event stores and other solutions, they probably have different ways of doing it, especially if they are polyglot solutions and have to account for multiple languages. So hard to answer how to do that in general, but that's how we do it.
Okay, great, great. Thank you for that. And also, one question from my side. I thought
Yeah,
about
sure.
that during your presentation. So, what you can recommend for, let's say, introducing the patterns, especially CQRS and river sourcing? Let's say, uh, how should we start if we have, let's say, brownfield project which is developed for a long time, and maybe we wanna improve something, change the ways of working and something like that. So what you can recommend us?
That's a very good question and a very tough one. I'll be honest with you. A few years back, I was watching presentations about DoD security event sourcing, and I was like, oh, okay, that's a very interesting idea, but that's totally impractical, right? And that because my background was, I was into enterprise Java at the time, and you had this mindset, what you do on a daily basis kind of forms, shapes your how you think about things, right? So it's really hard to move people from what they know and what they know works to something that sounds interesting, but hey, show me the real example. So for me, the deal breaker was when I saw huge production systems done with event sourcing securities, and then you realize that's not a toy, that's actually serious work being done by one of the biggest companies out there. But I think what needs to happen is more and more people need to start playing with this, in their homes, garages, free time, whatever, to just get the idea of how that thing works, and then they need to. So that they don't need to, but when they see an implementation of a real life huge system that actually works this way, then they can make a correlation between, oh, okay, so that my toy thing actually powers these big enterprises out there, and that's when you make a switch. I'm honestly think that if you just try to forcibly convince people that that's a very good thing,
Mhm.
right, while they're busy building their Kubernetes clusters, right, it's just not gonna work.
Yeah, yeah, exactly. I'm thinking the same. That it's always the approach with showing by examples that hey,
Yeah,
that problems for us. We can save money,
yeah.
time, and so on and so forth. Always helps us to change the, let's say,
Yeah, that
culture.
is just one more sentence. I know we are at time, but that's why one of the first things I did at Exonic as a developer advocate was to create a discussion platform so people can come and say, hey, I'm playing with this, and I have no idea how to model it, how to design it, or how to apply it. And then we have also experienced community members who can help you and tell you, hey, try this way and see. I think that is the key factor for pretty much any technology adoption, is to be able to show people how to do things when they're in the very early stage. And it is just interesting, but they still don't know the applicability of that thing. Uh,
Mhm.
but yeah, it's going to take some time, but I think we're getting there.
Yeah, yeah, for sure. It has to even take some time. It's not just like that change within the team of the whole organization. Yeah. Okay, so thank you, Milan, for your presentation. I can't see any more questions on our Q&A chat. So thank you
Thank you very
for
much.
your presentation, for your time, and I think everybody was enjoyed with your presentation.
I hope so. I hope so. Thank you very much for attending. Thank you very much for being with me today. Enjoy the rest of the conference, and I'll hope to see you someday live somewhere.
Yeah, I hope so. Okay, so
Uh,
our plan, we have now 1 hour lunch break, so we will meet each other within 1 hour. So take something tasty to eat, and we will catch later. See ya.
all right. Bye.